Hey, I thought I would do something a little bit different. What I wanted to do is do a very simple integral, cosine x dx, but we'll do it using the complex definition of cosine instead of normal methods. And I know someone in the comments is going to say, well, why don't you just, someone in the comments is going to say, well, why don't you just integrate it and be done in 5 seconds? Well, okay, we can do that. We'll just integrate this and we get sine x plus c. Okay, so for a starting point, we're just going to look at Euler's formula real quick. And Euler's formula tells us e to the ix is the same thing as cosine x plus I sine x. Now, if we take this and we actually plug in the negative in here, so if I just enter into this formula minus x instead of x, we have cosine minus x plus I sine minus x. But because sine's an odd function, this minus sign can come right here. And because cosine's an even function, this is the same thing as this, so we can just kind of clean this up a little bit. But with this, we can get a few useful values pretty quick. So if I just add these two together, on the left side here, we're going to have EIX plus E minus IX equals 2 cosine x. The sine terms cancel because of the negative sign there. And then if I just divide this by 2, we end up with our definition, these two's canceling out, that cosine x, this is our complex definition of cosine. Now the other thing we could do is we could subtract these two. Let's just do that really quick. And then when we subtract these, now the cosines are going to cancel and we're going to end up on the right side with 2i sine x. But then if we just divide out the 2i, okay, then we have our complex definition for sine. So that's where those two definitions come from. Let's save that and we'll continue. Okay, so given what we found here, we're going to just use, we have our definition of cosine right here, our complex definition. So what I'm going to do is integrate that just using that. So using this definition, so we're going to have, just write this in. Okay, so then from here, using the exponential functions, it's actually really easy to integrate. We'll just take a half up front. We can do this as two separate integrals, but okay, so integrating EIX is just going to be EIX, but we'll have an I in the denominator. And then for the second part, we're going to have e to the minus ix, but we're going to have, again, we'll have a negative I in the denominator, but I'll bring the negative right here. But then just cleaning this up a little bit, we have a common denominator right here, right? So I can pull these two things together, EIX minus E minus IX, and I'll distribute this 2 in, and we'll have 2i plus c. And just notice that's exactly our definition right there for sine x. So of course that was longer than doing the 2-second integral here, right? We got a couple steps, but it's still pretty easy to do this to get back to sine x. So this was pretty cool. Okay, so having did that and that works fine. Last, what we're going to do is, so this seems to be called complexifying the integral, and we'll do this just a little bit different. So for this, what we're going to do is go back to Euler's formula again. And so then for this, we notice for EIX, we have on the right side, we have this complex number. And we'll notice that we have two parts. We have here, this is the real part, okay, and this part is the imaginary part. So if we just take the real part of, using this notation, the real part of EIX is actually just cosine of x. So what I'm going to do is write it this way. We're going to do our integral, okay, and we're going to integrate EIX dx, but we just want the real part. So we have this, just to remember that we're taking back just the real part, but now we have an even simpler integral than what we did in the previous one. Okay, we're just going to integrate EIX. So the integral of that is just EIX over I. And we want the real part of this. But again, this is going back, this is just Euler's formula right here, EIX. I know it's very simple in this case, so we want the real part, and we're just bringing back Euler's formula, cosine x plus I sine x, but don't forget this I. So then just dividing through by this I, okay, we're going to have 1 over I cosine x plus sine x, as the i's cancel there. And then of course here we could rationalize this. We could multiply by I over I and get minus I, but it really doesn't matter because we're just taking back the real part, and we clearly see that this part here is going to be imaginary. So we can ignore that part. The real part of this whole thing is just going to be sine x plus c. So I do think this last case, complexifying, makes it a little simpler. You can't really tell it in this case because the problem's so simple, it doesn't stand out, but you do kind of save a little work. Anyway, hope that helped. Thanks everyone for watching. Have a great day.